And next up, we have Tony Colaprete, who is going to be talking to us about Viper.
Thanks. Okay, next slide. 5 minutes. This goes quick. Most of you have probably heard about Viper, and all of you understand that the last decade has been revolutionary in terms of our appreciation for the types and ranges of water on the moon. Viper's one of several next steps. If you saw Amy's talk, it fits in nicely into the broad set of steps needed to really get the information we need for sustainability. It's a lunar surface rover mission. It's really intending to conduct exploration science, which is modeled after terrestrial resource exploration. So it'll be really the first extraterrestrial resource exploration mission in many ways. We have our preliminary design review next month, towards the end of next month. So things are chugging along quickly. Our launch is scheduled right now for November 2023 to the South Pole. And if you want some more information, you can go to the website there. Next slide. The rover is about a 450 kilogram class rover, shown here. This is a bit dated. The neutrons, the 4 science instruments are highlighted with red boxes. There's the neutron spectrometer out front. That's actually a little bit higher now, raised up a little higher. It's similar to the instrument that Craig just described, slightly different technology, but doing the same sort of thing. We have a near-infrared spectrometer system and a M-Solo mass spectrometer system on the underside of the rover. And they are looking at the surface under the rover continuously, but also importantly, when we drill with the Trident drill, you can see it highlighted there. That's a 1 meter drill that brings samples up in 10 centimeter bites that we will examine with M-Solo and Nervous. Next slide. These are the Viper required measurements, and I'm not going to read through these here, but if this is being recorded, you can go back and pause and look at it. It is really a reconnaissance mission in such that it is all about getting lots of coverage and lots of areas of different thermal stability regimes with regards to water. It's trying to understand the range of possibilities, not necessarily hunt for water, but actually get the data that will help us constrain resource maps that we develop here on Earth. So it's meant to travel considerable distances. We've done a lot of analysis as to how much coverage is needed to get a certain certainty or uncertainty or confidence in our understanding of an area. It's definitely meant to go into multiple different regions, including PSRs. And doing all these measurements, looking at the surface and subsurface, it also needs to characterize the environment in which we're studying. So looking at temperatures, surface and subsurface temperatures, isotopes, the geology, mineralogy, et cetera. So it's going to return a wealth of knowledge in a broad set of thermal regimes. Okay, next slide. I'm rushing through this so quickly here. So this is an example of where we may go. This is an example traverse that we use to our site we use to develop.
I have about a minute and a half left.
Copy. Thank you. This is a site that's kind of northern of Belay. The figure on the right shows the fractional illumination using a 20-meter Lola DEM. And I've pointed out an area that we call a safe haven. It's an area that has considerably short periods of shadow. This is a place that we return to periodically to survive. The rover is a solar rover. It doesn't have any nuclear component to it. So to survive shadows, it needs good thermal systems and batteries, and that's what we do. We go to and from the safe haven, exploring the dark areas. You can see this is a nice area right here because we have all these dark regions that are within a few kilometers of this safe haven. Next slide shows a traverse for this same region. This is now shown on top of a 1 meter DEM that was constructed from a shape from shading analysis of NAC images. And the colors represent the different kind of ice stability regions we use.
30 seconds.
Thank you. Red is the PSRs. And I just include a little extra information here on PSRs for this group here is one of the requirements is that we have at least 224 meters of unique driving in a PSR, starting 30 meters within a PSR, and that's to account for uncertainty in the DEMs. and conduct at least one drill down to 100 centimeters. So we will actually be driving fairly deep into a PSR and getting quite a good coverage in these PSRs. Next slide. That's time. And then next slide is my summary, I believe. All right, there you go. There's my summary. Thank you.